Hello students, I am Sachin Prakash and I teach and mentor students in chemistry for IIT I believe that the real confidence which is required to crack this IIT exam will come only when you are confident in tackling good problems. And that clarity and understanding of concepts will only develop when you are really comfortable in handling these problems. So this video contains the paper discussion which I have conducted in my uh, classes online. Okay, and a lot of good doubts are there which I have discussed here. It will be helping you people in understanding, developing an understanding in how to approach and tackle good problems. Okay, and if you like this, if you found this paper discussion video to be useful and interesting, you can, like, comment, and subscribe to this channel, which will surely, motivate me to add some more useful videos of this type. Okay, because ultimately it's this is just an effort, honest effort, small honest effort from my side to help the student, uh, help my students as well as other students also in their ITJ preparation. So let us begin with this paper discussion. Okay.
Record mode. Yes. So this is getting recorded. Everyone should be knowing this. Okay, so I'm going to start the paper discussion now. 51 to 54. Everyone can see the paper in front of them. 51 to 54.
54.
54. Okay, let us see 54. In 54, you see, you are given a PV diagram. Okay, so what will be area under the curve? That will represent the work done, right? So what will be the work done? Work done, magnitude will be how much? Area under the curve. What is the area under the curve? It is half into, this is like 1 unit and this is also 1 unit. Half into 1 into 1 plus 1 into 1. Okay, and this will be in bar liter. Getting the point? And what is the sign? Positive, negative?
Positive.
See,
Negative.
it is expansion.
Negative.
The sign will be negative. It's like a minus of 3 by 2 bar liter. And bar liter is how much? 1 bar liter is 100 joules. This is minus 150 joules. Okay. Now you can write Q is equal to what? Delta U is equal to Q plus W. And Q is how much? Q is absorbed, so plus 100 joules. Minus 150. Minus 50 kilojoules. But are we committing any? Okay, it is a bar meter cube, not bar liter. Okay. So this will be in kilojoule. This will also be in kilojoule. See, 1 bar meter cube. It will be 1 bar into 1000 liters. That is 1000 bar liters into 1000 into 100 joules, the 100 kilojoule. Everyone is getting this?
Yes, sir.
Okay. So up to 54 it is done.
Sir, why
55.
53rd question is
Huh?
not option A?
Huh?
Why 53rd question answer is 0?
See,
Yes,
let,
sir. It should
okay,
be A.
okay, let us see 53. Okay, so just whenever you have these type of questions, no, it's better to draw a diagram. Okay, so I am starting with A. There is some state B. Okay, now when I am going from A to B, there is some energy change. Okay, so A to B it is 40. If the system goes from A to B by a reversible path, what will be net change in the internal energy? It will be 40 kilojoules only.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, answer will be 1.
40
Okay,
kilojoules.
yeah. Because internal energy change is a state function. It will not depend on which process you are taking, whether it is a reversible or irreversible process. Everyone is getting, see the answers which I have marked is as per the key which is given to me. Okay. After this discussion, I will give the key changes. Okay. So 53 is done, 54 is also done, 55,
Sir,
yeah.
sir, 53rd when it again comes to A means final and initial points are same.
They
It's
did
not,
not give it in number, sir.
They
it
didn't
is,
give cyclic process, sir.
it is giving A to B here also and A to B here also. It should have been B to A, then the answer would be 0.
Gave it as B to A only.
Huh?
Sir, in the paper they gave it as B to A.
Yes, sir.
Oh, they have given to
Yes,
me B to
sir.
A.
Yes, sir.
No, sir.
Every, huh?
No,
Yeah,
No,
sir.
sir. A to B.
A
You are
to B only. A to B
sir.
only they given, sir.
They gave like B to A, sir.
A
okay.
to
They
B only
gave
they
B
given,
to
sir.
A only, sir.
A
Yeah,
to
it
B
is,
only, sir.
okay.
Sir, B.
Then, see, if it is given to, as per the paper which is given to me, I will be proposing the key change. Are you getting my point? If the paper is, which, see, this is the paper which is given to the faculty. I don't know what they have given in the actual online test because it is not available to us. Whatever key change we have to suggest, it will be based on the paper only. Okay. So if half of the people got the question printed as B to A and half of the people got A to B, then the question will be deleted only. Either it will be deleted or both 1 and 4 will be the option. Are you getting my point?
A to B only they given, sir.
Yeah, means I'm just telling you what will are the possibilities. If it's like that, so based on what paper I am having in front of me, the answer should be 1 only. Okay. So we can move forward. See, right now you should not be very much worried about how much marks you are getting. I know that you people have a habit of, getting good marks and you want to continue getting good marks. But you see, the idea is to know where the things are correct or incorrect. If you have that understanding, other things, these marks are just temporary marks. You will do well in every test if your understanding is good. Okay. As far as corrections are considered from my side based on this paper, I will send this as a correction. Okay. And so most probably this will go for delete or, both options will be correct. But I think it should go for delete. If
They
half the,
given, sir. A to B only, sir.
so that is the thing. So after 53, up to 55 to 57.
55.
55. Now you see 5 moles of an ideal gas is expanded isothermally from 5 liters. This is 5 dm cube is 5 liters to 5 meter cube is 5,000 liters. What is correct about the gas? Now you see, if your volume is increasing by 1,000 times, then pressure will decrease by 1,000 times. That is correct. Okay, because temperature is constant given. There will be no change in the enthalpy of the gas. If it is isothermal, delta T will be equal to 0, and everything which is, containing delta T will be equal to 0. Delta T will be 0, delta U will be 0, delta H will be 0. So these two are also correct, so obviously one will be incorrect. It's not an adiabatic process, so Q won't be equal to 0. Getting my point?
Yes, sir.
55 is done.
Sir,
56.
57, it's not like TV per gamma minus 1 is constant.
See, whenever the term constant external pressure is mentioned, it's an irreversible process. Okay. See, a process cannot be adiabatic and constant pressure at the same time, and reversible also. Getting my point? If it is adiabatic, then if it is adiabatic, then it cannot be a constant pressure process if it is a reversible adiabatic process. Okay.
So then what is the answer?
Answer, see, do you want me to solve it?
Yes, sir.
Yes, sir.
Okay. Let us do this. Okay, so you see, it is given in question number 57 that V1 is equal to 1 liter and V2 is equal to 2 liters. Okay, so what is the work done? It will be minus of the external V2 minus V1. It will be minus of 1 into 2 minus 1. It will be minus of 1 ATM liter. It's expansion, so we are getting the correct sign. Okay. Now, after this, it is saying it is 1 mole of monoatomic gas and at T Kelvin. Okay. Now you see, I can always write delta U is equal to Q plus W. And I know Q is equal to 0. So what will be delta U? Delta U is N CV delta T. That is equal to W. What is W? Minus 1. So I can write N is how much? 1. So 1 into R by gamma minus 1 into delta T is equal to minus 1. Okay. So I can write gamma is how much for ideal gas? 5 by 3. Monoatomic gas, gamma is 5 by 3. Okay. So I can write it as R by 5 by 3 minus 1 into T final minus T minus 1. I want to find T final. So this whole thing will be R by 2 by 3 into minus, if I multiply everything by minus, so T minus TF, that is equal to 1. So I can say that T minus TF is equal to 2 by 3R. So TF is equal to T minus 2 by 3R. R is 0.021, so answer is 3.
Sir,
Getting my
why
point?
can't you consider V per gamma minus 1 as constant?
Because you see, it is given constant external pressure and it is
Both,
adaptive. So it is,
they cannot give, no, sir.
if both are given, then it is irreversible. PV to the power gamma is only applicable for reversible adiabatic process. Are you getting my point?
Yes,
If you
sir.
yes.
56, I am getting option 2, sir.
Okay, let us check 56. Okay.
No, sir, option 1.
Okay, let us see. There is no problem in that. So you see in 56, you have 16 gram of O2. That is 16 by 32 moles of O2. That is 0.5 moles. The only mistake which can be done is done here only. So if that is not the case, then you see the pressure is given.
Okay, sir. I understood, sir.
Huh?
I understood, sir. Why it's option 1.
Yeah, okay. You might
Okay,
have
sir.
taken 16 by 16, so n will be equal to 1.
Yes, sir.
Yeah, that is the whole purpose of giving this question. These are very small mistakes. Okay, do not be too sad about it. Okay, just keep it in mind. Okay. After this, 58%.
Sir,
Yeah.
sir, in the 56th one, what does in 100 is equal to 4.6 mean?
In 100, no, it is ln of 100. Okay. ln of 100 is basically 2.3 log 100. And log 100 is 2. So whether they give it or not, you should be able to do it yourself. Getting my point?
Yes, sir.
Okay. So after this,
58, sir.
58, sir.
okay, 1 minute. Okay. So 58, it is given that the whole process is related by a process PV to the power n is equal to constant. So here, this is a polytropic process, where n is the polytropic exponent. So can you remember what was the Pn will be equal to what? Do you remember what was the formula? Like Cv plus R by 1 minus N. Something like this it was. Can you verify? I've forgotten the formula.
N minus 1, sir.
N minus 1.
Okay, 1 minute. Is Cv plus, yeah, it is something like this only. Okay. I have given it as Ck is equal to Cv plus R by 1 minus K. They are using N instead of K. Are you getting my point? Yes, no? Are you getting this formula first?
Yes, sir.
Okay, once you have gotten
Yes,
this, you see, they have given that Cv will be equal to R by gamma minus 1. Okay, and they are saying that this should be equal to 0. So if this is equal to 0, this means you can write Cv is equal to minus of R by 1 minus N. Okay, this means you can write R by gamma minus 1 is equal to R by N minus 1. So N is equal to gamma. Getting my point?
sir. How is it a polytropic process, sir? How
See,
is it a
what have
polytropic?
I told in polytropic process definition? That polytropic process represents a general process. See, if the equation is given, no, this means it is a reversible process. Okay. If it is not given that n is gamma, then this means that it is what you say as a polytropic process. If n is given to be gamma, then it is a reversible adiabatic process. Are you getting my point? You can do it without this equation also. You see, PV to power n is constant, and you are saying molar heat capacity is 0. You see, if C is 0, then delta Q is equal to 0, where delta Q is 3 dt only. So delta Q is equal to 0. This means that the process is adiabatic. Are you getting my point?
Yes, sir.
So I have given you both the mathematical way and the logical way of doing it. You can use any one of them depending on your understanding. Is it clear? Yes, no, something.
Yes, sir. Yes, sir.
Okay. See, after every explanation, if you people are not having doubt, if you are having doubt, you will say. If you are not having doubt, automatically just one of you, two of you say yes, I will get the, signal that I should move on. Okay. Otherwise, I will be waiting till someone says something. Okay. So after 58,
Sir, 61.
61,
59.
60, sir. 60.
50. Okay. 59 is a doubt. Yes.
59.
Okay. Let us see 59. I will discuss all the problems. There is no issue. If you have doubt, I will discuss it. Okay, now you see, it is given that you have 2 moles of an ideal gas which is undergoing reversible expansion from 4 liter 400 K to 8 liters. Okay, such that TV to the power square is constant. So what will be the change in the enthalpy of the gas? Okay, now you see, all you have to do is find the temperature, final temperature. So you can write T1 V1 square equal to T2 V2 square. T1 is how much? So I can write T2 by T1 because I want final temperature is equal to V1 by V2 square. What is V1? V1 is 4. No,
4L.
not 8 square. It is 1 by 4. So I can write T2 is equal to T1 by 4. It is equal to 100 Kelvin because T1 is 400. Okay. So you see, and I know that it is the ideal monoatomic gas. So gamma is equal to 5 by 3 and CV is equal to R by gamma minus 1. Okay. So CV is basically 3 by 2R. Okay. And CP is 5 by 2R. Okay. So delta H will be equal to NCP delta T. N is given to be 2, Cp is 5 by 2 R into delta T is 100 minus 400. The 2 will cancel out, it is minus 1500 R. Everyone is clear with this? See, enthalpy is always equal to NCP delta T. It doesn't matter which process it is following. Getting my point, everyone?
Yes, sir.
That is very good. Yes. After 60,
60.
60 is a doubt? Yes or no?
Yes, sir.
Okay. So you see, they have given PT diagram. Okay. And they're asking the magnitude of work, net work done by the cyclic process. Now you see, if PT diagram is given now, you have to convert it into PV diagram to get the force, net work done. Okay. So what we have to do here is, we have to, so this
Your
is question.
voice is not audible, sir.
Okay, 1 minute. Can you hear me, everyone?
Audible.
Yes,
Yeah.
sir. Yes, sir.
Yeah.
Audible, sir.
Right now I'm not teaching, so I'm not shouting right now. Okay. So if it is not audible, you just ask, I will say again. Okay, now you see, I have to find volumes at all these 4 points. Okay. So what will be the volume at A? What will be VA? It will be nRTA by PA. Is it correct? Okay, now what is PA? PA is 1 atm. Not just TA, TA is 300. So I can write it as 300 into nR. Okay. Now you see what is TB, VB? VB nR into TB. TB is how much? TB is equal also 300 by PA. PA is not 2. It is 150 nR. What is VC? VC is equal to C is N into R into temperature is 400. My pressure is how much? 200 nR. Okay. And VD. VD is equal to how much? VD is equal to N into R into
400.
400. So 400 nR. So you see you have got 4 different values of volume. Okay. Now how to draw this? You see if I'm drawing a PV diagram, okay, then I can draw these 2 lines. Okay. Let me just change the color. Okay. Suppose this is the color I'm taking. Okay. So suppose this is like 2 atm and this is like 1 atm. Okay. Now let us say that I am drawing this diagram. First I have to point out A. Now you see A will be at a lower temperature. Okay. So let me draw 2 isotherms also, because you are having only 2 temperatures. So if I am drawing 2 isotherms, let me draw it by this color. So one isotherm will be going like this, and another isotherm will be parallel to this. Moment. Are you getting my point? Okay. So this is corresponding to T is equal to 400. This is corresponding to T is equal to 300. Okay. This is T. And let us say that this is 2 atm. Okay, because it is not visible. This is 1 atm. And this Kelvin. Now, point number A. Point number A is at 300 Kelvin and 1 atm pressure. So this is the 300 Kelvin and this is 1 atm. So this will be my point A. Okay. Second is point B. Point B is at 2 atm. So 2 atm is this line and 400 Kelvin. So it is point B is here. Then point C is at 2 atm pressure and 300 Kelvin.
Sir,
No. This I have done wrong. This is point
B 320.
This is point B, no? Okay. Point C is at 2 atm and 400 Kelvin. So this is point C. And point D is something like this. 400 Kelvin and 1 atm pressure. So now I can draw my process. So these 4 points are joining like this. Okay, and the sense of the curve is A to B, B to C, T to D and D to A. Okay. Now they are asking what is the work done. Okay. See, I am taking this question in general so that you can do it without drawing this also, but I am just taking it to give you an idea how to draw the curves. Okay. Now you see, now we analyze the processes individually. A to B. What type of curve is process it is? It is isothermal. Okay, so if it is constant T, what will be W? W A to B will be minus nRT ln of VB by VA. So T is here TA. Okay. So this will be equal to what? Minus of nR. TA is how much? Into 300. ln of VB. VB is how much? 150 nR by VA is 300 nR. Okay. So you see this will cancel out as 1 by 2. So you see this is the compression because pressure is increasing. Right? So work done will be what? Work done will be positive. It's minus 300 nR into minus of ln2. It is 300 ln2 into nR. Okay, I will put the value of n and r later on. Okay, second B to C. You see B to C is a constant pressure process because P is constant. So I can write work done is equal to minus P into V2 minus V1. That's VB, VC minus VB. So minus P is 2 here. VC is how much? 200 nR. Minus VB is how much? 150 nR. It's an expansion. It is minus of 100 nR. Okay? C to D. C to D is again an isothermal process. So W will be equal to what? Minus nRT. So here T will be 400. ln of VD by VC. It is minus nR into 400 ln of VD by VC. So ln of VD is how much? 400 nR
400 by 200.
by 200 nR. Now you see this is an expansion. So work done should come out to be negative. This is minus 400 ln2 into nR. So you see I have got all the, one last one will be WD to A. Again it is an isothermal, isobaric process. W is minus P into VA minus VD. Minus 1 into VA. VA is how much? 300 nR. Minus VD is how much? VD is 400 nR. So you see, it's basically a compression. So because work done will be coming out to be positive. So what will be work done total? W total will be equal to W of AB plus W of BC plus W of CD plus W of DA. So you see this is like 100 nR. This is like 4 minus 400 ln 2 into nR. Just adding it here. Plus what is WBC? Minus 100 nR. What is WAB?
300 ln to nr.
300 ln to nR. Okay. So you see this will cancel out, and 300 minus 100 will be minus 100 ln 2 NR. So answer now,
N is 2, sir.
so N is 2. So it is minus 100 ln 2 into 2R. So minus 200 ln 100 minus of 200
100
ln
4R.
2R. So it is minus 100 ln 4R. So they are asking magnitude of the network. So it will be positive. Are you getting my point?
Yes, sir.
Okay. So you see, what actually you have to do is A to B, B to C, C to D, and D to A. Okay. That you have to do separately. This part I have just told you so that if someday it is asked in a question, you should be able to do it. Okay. But the actual question answer will be this one. Okay. After 60.
62. 61, sir.
61.
Sir.
Okay. 61. The temperature is changing from 300 to 900 Kelvin. This is T1 and this is T2. And you know N, and it is monoatomic, so CV will be what?
2.
CV will be 3 by 2R. And so can't you find delta S? CV ln T2 by T1 plus R ln V2 by V1. Here it is isochoric, so V1 will be equal to V2. You want me to calculate also? Or can you do it?
We can do so.
Delta S is equal to CV ln T2 by T1
Can do so.
plus R ln V2 by V1. It's a simple formula which you have to apply. This will become 0. Okay, CV is 3 by 2R into ln of T2 is 900 and T1 is 300. So it is basically 3 by 2 into 3 by 2R ln 3. So it will be positive, so it will be increasing, and R value is 2. It is 3 ln 3 calories.
And
They should
CV
mention per calorie per. Okay, R they have not given. No? Acha, into 2 will be there because whole thing has to be
N value
multiplied. Yeah, into 2. Into 2. So there are 3 R ln 3. Yeah. Okay, after this 61 is done. 62.
62.
Huh? 62.
62.
Okay, let me check 62.
Sir, one scroll up. Sir.
Yes. This one.
Yes, sir.
Is it okay? Okay, in 62 it is given that
Okay.
gamma is 4 by 3. Okay. And it is 2.5 calorie per Kelvin mole at 1 bar. What is the standard molar entropy of the gas at 323 degrees centigrade and 1 bar? Okay. So you see, it is given, I have given this thing, no? Delta S T2 minus delta S T1 is equal to delta Cp ln T2 by T1. Have I given this formula? Kirchhoff's law?
Yes, sir.
Okay.
Yes, sir.
So here delta Cp is given to be how much? delta Cp is equal to 2.5. Okay, into ln of T2 by T1. This is ln of, what is T2? T2 is 323 plus 273. So 323 is basically 3 to by 600.
600 Kelvin.
So 600 by 298. Okay.
Sir, how
And
delta Cp is 2.5?
it is given, See, there is no reaction
Molar
taking place. So
entropy is
Cp and
given.
huh? Cp, see,
Molar
if this,
entropy of an ideal gas.
yeah, molar entropy is given, no? See, if there is no reaction, delta Cp will be equal to Cp only. Are you getting my point?
Yes, sir.
Okay. So delta ST1, this is given to be what? 2.5 minus delta ST2. This we need to find out. So T2, so this is approximately going 2 times. So it is basically delta ST2 is equal to 2.5 to 1 plus ln 2. Okay. So 1 plus ln 2 will be how much? ln 2 is 0.7. So it will be 2.5 into 1.7.
4.25.
So it will be, yeah, I think 4.25. What else is, are we missing something here?
Sir, delta Cp will be 4 also. Gamma equals to 4 by 3.
Yes, sir.
Okay, this is given to be 2.5. Delta Cp is not given. Okay. Yeah, we have to find out. Yeah, that is the mistake I am doing. So you see, it is given that gamma is equal to.
Sir, your screen got stuck, sir.
Okay. That was supposed to happen once at least. Otherwise, it won't be fun. No? Is it clear now? Yes.
Yes,
Yes,
sir.
sir.
So you see, gamma is 4 by 3. Okay. This means that Tp
3R.
is equal to
4R.
gamma r by gamma minus 1. It is 4 by 3 into r by 4 by 3 minus 1. Okay. So it is basically 4r. Okay. So I have to use 4r here. Okay. And so it will be 2.5 plus 4 into r is 2. Okay. Into 0.7. Okay. So it is 8 into 0.7 is 5.6 plus 2.5, it will be 8.1. Are you getting my point? Yes or no?
Yes, sir.
Yes, sir.
Okay, so after this, 63 is a doubt?
65, sir.
65.
Sir, 63.
63, sir.
63 also. Okay, don't worry. Okay, in 63, they are saying H2O solid is going to H2O liquid. So it is basically fusion. There is some delta H fusion associated with it. Okay, now you see entropies. What is delta S for this reaction? It will be S of liquid minus S of solid. It is equal to how much? What is S of liquid? It is 58 minus 38. It is 20 joule per mole Kelvin. And you know delta H fusion is given. It is not given. But temperature is given to be 273 Kelvin.
273 Kelvin.
So delta S fusion
273.
H fusion by T fusion. What is happening? It has got stuck. Oh, it is working here. Why is it not working here? One minute. Okay, let me just close it once and go back. There's some software glitches today. Is the recording going on?
Yes,
Yeah.
sir.
Yes,
Yes,
sir.
sir.
Okay. From here onwards, whenever we have a paper discussion, no, you just remind me of recording it on Teams itself. Okay. So that way, those who are not attending the recording, the class, can look at later. Now, you should not use it as an excuse for not attending the paper discussion. Okay. But because we have been told not to give you people like, one minute. We have been asked not to give you people as what you say, delta H fusion by, what will be delta H fusion by T fusion? So delta H fusion is equal to 20 into 273, so 5463. Okay. See, I always believe in helping students in all the issues because you people are new to this preparation. But at the same time, what happens that people start taking undue advantage of that, okay, which management doesn't want. See, I don't care that much whether you are attending classes or not, or attending paper discussions or not, because I believe that if you are very good, then it won't hurt you that much. But if you are just lazy and not attending, then it is going to be a disaster in the future. Okay, because others will enhance their understanding and they will get ahead of you. But then not everyone, I believe that not everyone will be qualifying this exam. Those who are more sincere, more hungry will ultimately get this seat in IIT. So that habit and that attitude has to be there right from the beginning. Okay, so that sincerity is non-negotiable in this preparation. See, there was a time when the intelligent people could have cracked this exam very easily. Okay, but now the game has changed because now everyone has access to proper coaching, proper resources, proper videos, everything. So then those who are sincere and hardworking will get ahead of those who are intelligent but lazy. Okay. So this you people should keep in mind because it is just starting days of your preparation. Okay, should be at least attending all the classes sincerely. Okay, even if you know the things in advance, okay, just listen to what extra points which are there in told by. Treat it as a revision if you know everything in advance, and if you don't know, then you should naturally be attending it. Otherwise, you will miss the things. Okay, so after 63. Is 65 a doubt?
65.
65.
Okay, 65. Let us see. See, in 65, X gram of KHC2O4, okay, requires 100 ml of something. Okay, so first reaction is KHC2O4 plus MnO4 minus. Now, this is a redox reaction, so we'll be getting CO2 plus Mn2 plus. Okay, this will be my reaction. Now you see, suppose molar mass is M. Okay, I'm not interested in calculating because they're asking ratio. So M will get cancelled out somewhere. So you see, you are starting with X by M moles of the substance in first case. So, and what will be the n factor of C2O4 2 minus? See, plus 3 is going to plus 4. For how many atoms? 2 atoms. So the n factor here will be how much? 2 for redox reaction. Are you getting my point? Everyone? Yes or no? Okay. So you see, X by M moles means how many equivalents? X by M into 2. This should be equal to moles of equivalents of MnO4-. So it will be 100 into 0.02. Okay, so let us say that it is millimoles only. Okay, it will hardly matter. Or if it is X by M moles, then it will be 1000 X by M millimoles. Okay, let us do it properly only. So if I am writing 1000 X by M into 2, it is equal to 100 into 0.02 into 5, where n factor of MnO4 minus is 5 in acidic medium. So this will be, so I can write 2000 into X by M is equal to, what will be the calculation? It will be 10. So X by M will be 1 by 200. This is my first equation. Okay, second case, KSC2O4 is now reacting with calcium hydroxide. And it is an acid-base reaction. How many acidic hydrogens it is having?
1.
It is having only one acidic. Its n factor is 1. How many OH minus it is having?
2.
Its n factor is 2. Okay, so I can always write milli equivalence of acid is equal to milli equivalence of bases. So milli equivalence of acid will be 100. What is the milli equivalence? 1000 X by M millimoles into n factor. 1000 X by M into n factor is 1. That is equal to milli equivalence of base. It will be equal to 2 into n factor is 2 into 100 ml volume into 0.05 is the, it is like 2 into 5, 10. Okay, from this I can say, so this is Y actually, not X, because you know here we are starting with Y grams, so Y by M moles. Okay, or 1000 Y by M millimoles. So 1000 Y by M is equal to this. So from this I can write Y by M is equal to 10 by 1000 or 1 by 100. Are you getting this? So from this I can say X by M by Y by M.
KHC2O4 in second reaction is 1.
Huh?
How n factor of KHC2O4 in second reaction is 1.
Yes. Have I written something else?
How it
Why
is
is
1, sir?
it?
How it is 1? Okay, just 1 minute. See, how many H plus it is given? Only one H plus, no?
But in before reaction it is 2.
See, this is an acid-base
Again, it's
reaction.
present sharp.
This is a redox reaction. Both are separate reactions, so a same substance will have different N factors in different types of reaction. Are you getting my point?
Yes, sir.
Okay.
So,
Yes. How?
nothing, sir.
Yes. Okay, so after 65, next
67.
67.
66 is a doubt?
No.
Yes, sir.
Yes, sir.
Okay,
Yes.
I will discuss it. Okay. See, it is a fairly, simple question. You see, we have a mixture of NaHCO3 and Na2CO3. Okay. Now you see, suppose you are having A moles of this and B moles of this. Okay, and see, the normality is not given, so I am assuming that it is a one normal S here, just for ease of calculation. So with phenolphthalein, okay, milliequivalent of only Na2CO3 will react, right? And with phenolphthalein,
Yes, sir.
only this reaction will be taking place. So you see, what is the milliequivalence of here? N factor of Na2CO3 will be equal to 1. So what is the milliequivalence of bases? Milliequivalent of base will be equal to milliequivalence of acid. So it will be initially you are using X and one normal, and that is equal to milliequivalent of base. You have A millimoles, B millimoles of Na2CO3 into N factor is 1. So in first case, B is equal to X. Okay. Second case is YML is further required with methyl orangeous indicator. Now you see, my reaction in the first step was Na2CO3 going to NaSCO3. Now initially, I am starting with how many moles of Na2CO3? A. And how many moles of, B. And how many moles of NaSCO3? A. Now after the reaction is end, this will become 0 and this will be A plus B. Are you getting my point? Basically the reaction is Na2CO3 plus H plus gives NaSCO3. Okay. Na2CO3 plus 2H plus giving 2 NaSCO3. Are you getting my point? Yes or no?
Yes.
Okay. So 1 millimole of Na2CO3, A millimoles of Na2CO3 will give, it should be only 1 H plus. Okay. So after the reaction, you will have A plus B millimoles of NaSCO3. So next step, when NaSCO3 is going to H2CO3. Okay, this is the only base which is present, and it will be indicated by methyl orangeous indicator. Okay. So you see, you are having what you say as. Okay, let me just write it as HCl because I feel like you people might be getting confusion. So I will be writing it as NaSCO3 plus NaCl. This is the balanced equation. Okay. So you see NaSCO3 going to H2CO3. You have A plus B millimoles. Okay. So this will be the milliequivalence of base. N factor here will be 1 only because it is only taking 1 H plus. So A plus B into 1 will be equal to Y into 1 normal. So you see A plus B is equal to Y, or A will be Y minus B is equal to Y minus X. So I think they are asking
Number of millimoles of NaHCO3 is A plus B.
see, after the first step it will be A plus B.
Initially, we also have A millimoles of NaHCO3, no sir?
Yeah. Initially we have A. After the, so we have written B and A here. B is completely consumed, and here you will be getting B. So after the first step, you will have A plus B millimoles. That will be indicated by methyl orange. Are you
Now
getting
A plus B plus A, 2A plus B should be, no sir, then?
Now it is saying that volume of HCl for complete reaction of NaSCO3 only in the original mixture, not after the first step wala mixture. Are you getting my point? In the original mixture, you have only A millimoles. Getting my point?
Yes, sir.
Okay. So after 66,
67.
67. Okay.
67.
67 is a question which I have discussed it in the class. Only the values are slightly different, but other things are same. Okay, let us try this question. You see, the bleaching powder contains OCl minus. Okay, which formed when chlorine is dissolved in the water. Okay, so that is good. To determine the concentration, it should not be determine, to determine the concentration, we treat it with Ki, which is the iodometric titration. You will be getting I2. And this I2 will be estimated by using I2. Okay. Now you see, ClO minus will go to Cl minus. So N factor will be 2, because plus 1 is going to minus 1. This question itself I have discussed in the class. So you see, what is the milli equivalence of hypo? It will be 17.4 into 0.2 into 1. It will be equal to 3.48 MEQs. So this is also 3.48 MEQs. Okay. And then this will also be 3.48 MEQs. Okay. So this will be 3.48 by 2. Millimoles of OCl minus. Now you see, 1 mole of calcium or bleaching powder contains 1 mole of OCl minus, and it also contains 1 mole of Cl2. If it is decomposing, it will give 1 mole of Cl2. So I can say moles of OCl minus is equal to moles of Cl2. So I can say that it is equal to 1.74 millimoles of Cl2. What is happening? Why is it freezing? Okay. Okay, let me just. Oh. Okay. So you see, I am having 1.74 millimoles of PL2. Now you see, how many 25 ml of the sample contains 1.74 millimoles of Cl2. So 1000 ml, which is 1 liter, will contain how much of Cl2? You're multiplying by 40 here, multiply by 40 here, so 1.74 into 40 millimoles of Cl2. Now I can convert it into moles, 1.74 into 40. What am I doing? by 1000 moles of Cl2 into 17 will give us 1 will give us grams of Cl2. So they are, I think, asking how much mass of chlorine will be there in 1. So if you are doing this calculation, this will go like this. So we take it to 1.74 into 2.84 grams. So the 4.94 grams, something like this. 0.7 into 2.84. Should be 4.94 grams. Have we done something? 117.4 into 0.2 is 3.48, 3.48, 3.48 by 2 is 1.74. So 1.74 into 40 by 1000. So should be 4.94 grams, not 4.494 grams. Oh, let me check. Okay, here they have taken it to be 0.02. Are you getting my point? What was the question in your, what do you say? This. What is, was it 0.02 or 0.2?
0.2 only, sir.
0.2 only. Then this is also going for correction. None of these will be the answer. Answer should be 4.94 grams. Are you getting my point? This will go for delete. Anyone who got 4.94 grams as answer?
Yes, sir.
Okay.
Yes, sir.
So what did you mark? You marked 2.
I didn't keep anything, sir.
Okay.
I'm not sure.
Okay. Then it is going for delete actually. None of the options are matching. Okay. After this, 68,
69.
69.
69.
68.
68 is a doubt. Okay. You see, you have to just calculate a molarity and from that you will get the answer. You see, milliequivalents of MnO4 minus will be equal to milliequivalents of H2O2. MnO4 minus is going to Mn2 plus, so its N factor will be 5 into volume is 50 into 0.1. That is equal to 10 into N factor is 10 into molarity is M into volume is 2. N factor is 2. So from this, 25 by 20 is molarity of H2O2. If molarity is basically 1.25 molar. Okay, so what is the volume strength? Volume strength will be 11.2 into molarity, which is 5 by 4. So it is how much? It's 14 volume. So we know that 100 volume is having volume strength of 30% W by V. So 14 volume will be having 0.3 into 14. It will be equal to 4.2. So answer should be 1. Getting my point? I have given this point in the notes also. That if you know the molarity of H2O2, calculate volume strength and use that per hydrol is 100 volume and its volume strength is 30 W by V. From that also you can get it directly. Everyone is getting this?
Sir, could you explain again?
See, milliequivalents of MnO4 minus is equal to milliequivalents of H2O2. N factor of H2O2 is 2, molarity is M, and volume is 10. MnO4 minus molarity is 0.1, volume is 50, and N factor is 5. From that, you can get a molarity of H2O2, which will be 5 by 4. So volume strength will be 11.2 into molarity of H2O2, it will be 14V. Now, we know that 100 volume H2O2 is 30% W by V. So 14 volume will be 4.2. So answer is 1. Getting my point?
Yes, sir.
Okay. After 68,
69 is
69. See, first equation is an acid-base reaction. So Na2CO3 plus H2SO4 giving products. Okay. So I can say milliequivalents of Na2CO3 will be equal to milliequivalents of H2SO4. Now, which is milliequivalents of Na2CO3? It is 25 into normality is given directly. It is 1 by 10. H2SO4 10 into its normality is given to be, let us say it is N, or let us say it is X. So from this I can say that X is equal to 0.25 normal. That's the H2SO4 normality. So you see how volume of water which should be added to 400 ml of this solution, make it N by 10. So see, suppose I am adding, I am taking 400 ml of this.
Sir, your screen got stuck.
Okay, 1 minute. Is it okay now? Can you see the cursor moving?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now you see, I can write N1 V1 is equal to N2 V2. So what is N1? N1 is 0.25 into V1 is 400 is equal to N2. N2 is something which is given 1 by 10 into V2 is 400 plus Y. Y is the volume which is added. So you see, from this I can get 1000 is equal to 400 plus Y. So Y is equal to 600. Are you getting this?
Yes, sir.
Okay. So after this, tell me
70.
70 is a doubt. Okay. You see, it is given that 1 gram of metal carbonate was dissolved in 25 ml of normal HCl. Normal HCl means 1 normal HCl, basically. So the resultant liquid required 50 ml of N by 10 NaOH for caustic soda is NaOH for complete neutralization. Okay. So what will be the? Okay, so you see, basically, I'm starting with some carbonate, okay, MCO3, and say I am taking Y millimoles of this. Okay, so you see, Y millimoles of, and this Y millimoles is having weight of 1 gram. Okay, so you see, Y millimoles of carbonates will give Y millimoles of CO3 2 minus. Okay, so let us say that it is MXCO3. X is the, some sort of valency. So, 1 minute. So you see, I was having some carbonate ion and I was treating it with HCl. And the extra HCl reacted with NaOH. Okay, the reaction is finished. What is the milli equivalence of NaOH? It is 50 into 1 by 10, 5 MEQs. So this is also 5 MEQs. Now how much HCl did we start with? It was 25 into 1, 25 MEQs. So how much HCl was consumed in this step? It is 25 minus 5 is 20 MEQs. So you see, what is the weight of milli equivalence of carbonates? It is 20 MEQs. Now whatever is the milli equivalence of carbonate will also be the milli equivalence of, MCO3. So you are having 20 MEQs of the metal carbonate, MxCO3, which is weight 1 gram. So you see 20 into 10 to the power minus 3 equivalent weighs 1 gram. So 1 equivalent will be weighing 1 by 20 into 10 to the power minus 3 grams. So it will be 1000 by 20. It will be 50 grams.
50.
Okay. 70 is done. So after this 71, 72.
Sir, once again, could you explain from 20 MEQs of CO3 2 minus?
See, 20 MEQs of CO3 2 minus will be 20 MEQs of MxCO3 because all of the carbonate ion is coming from the metal itself, the metal carbonate itself. Okay, and that is weighing 1 gram. So you can find the equivalent weight of metal carbonate. Getting my point?
Yes. Yes, sir.
71, 72.
71, sir.
70,
70.
71 or 72?
71, sir.
71.
71. Okay. Now you have to just find the work done, no? Is there any problem in finding work done? You people are asking work done problems very much. So you see, basically what is happening is that you are having 8 grams of oxygen. It is 8 by 32 moles of oxygen. It is 0.25 moles of O2. And you see, it is expanded isothermally at a constant external pressure. Means work done will be equal, this is an irreversible process. It is minus P external into V2 minus V1. Minus P external is 4 bar into it's 2 dmq to 8 dmq. V2 is 8 liters, minus V1 is 4 liters. Sorry, 2 liters. So it is like minus 24 bar liter. So it is minus 2400 joules. Okay, so magnitude of work is 2400 joules. And that is equal to mgh. It is 40 into G is 10 into H is equal to 6. Are you getting my point?
Yes, sir. Yes.
Wherever the term constant external pressure is mentioned, it is an irreversible process. A process cannot be isothermal and isobaric or isothermal and adiabatic at the same time if it is reversible. Only irreversible processes can be constant. with respect to two parameters at the same time. Okay. After 71,
72.
72. Okay. So you see, here it is not given that the gas is an ideal gas. It is only given that U is equal to 1.5 PV. Okay. So I can say that delta U is equal to 1.5 into delta PV. Okay. Now you see delta H is equal to delta U plus delta PV. This is equal to 1.5 delta PV plus delta PV. 2.5 into delta PV. Okay. So you see, it is heat absorbed at constant pressure. Okay. Will be equal to delta H. So this is 2.5 into P is constant, so it can come out of the things. It will P into delta V. P is like 100 kilopascals. Okay. Or it is 1 bar. Okay. Into V2 minus V1. So V2 minus V1, this is like 0.2 liters and it is 0.1 liters. Okay. So 0.2 minus 0.1. 2.5 into 0.1 into bar liter. 1 bar liter is 100. Okay. This is the problem which is coming very frequently. Okay. So, I have to save it. Okay. Some glitches are there. So this will be equal to no, it is not working. Okay. Yeah, it is working. I think I have to do something. So this is like 100 joules. So it is how much? 250 joules. 1 bar into 1 liter is 0.1 bar liters actually.
25 joules.
20.
1 minute. Yeah, it will be 25 joules. But
They asked in kilojoules.
so the answer should be 0.025.
Yes, sir.
It's a decimal integer question. This will also go for delete if we follow the previous thing. Okay.
Answer we have written, sir, 0.02.
See, the thing is no that they had it in mind that the answer should come accurately in 2 decimal places. But you see, The number of significant figures, the last significant digit is going to the third decimal place. Okay, so numerical value won't give the correct answer, the representation.
Yes,
Okay, so they will go for delete. That I am telling you in advance. Okay, so just know that this is the process. After 73,
74.
This is 70.
4.
74,
73.
73 is also a doubt.
Yes.
Yes, sir.
So you see in 73, basically what you have to do is that for a mixture, Cp mixture will be equal to sigma Ni Cpi by sigma Ni. I think I've given this in the notes also. So it's like 3 into 2.5 R plus 2 into 3.5 R by 3 plus 2. It is like 7.5 R plus 7 R by 5. It's 2.9 R. Have I calculated it correct?
Yes, sir.
Okay. Then what is the Cv mixture? It will be Cp minus R, 1.9 R. And delta T is 100 Kelvin. So delta U, Cv delta T, 5 into Cv into delta T. It is 5 into 1.9 R into delta T is 100. So R is 2. It is like 19 into 100. 1900. Are you getting this correctly?
Yes, sir.
After 73,
74.
74. How many energies available? Okay, for sustaining muscle and nervous activities. Basically, it is asking about useful work. So W max useful will be equal to minus of delta G. Well, so loss of free energy is available as useful work for us. What is delta G? Delta G is delta H minus T delta S. What is delta H? Delta H is minus 2808 110 power 3 minus T is how much? T is 273 plus 37, 310 into how much is this? 200. So you see, if you are doing the calculation, you are taking 10 power 3 out, it is minus 2808. Okay. And minus 62. It is minus 2870 into 10 power 3 joules. Minus 2870 kilojoules. So W max useful will be minus of delta G plus 2870 kilojoule per minute. Are you getting my point, everyone?
Yes, sir.
Okay. So this brings us to the last question of the day. Is it a doubt?
Yes, sir.
Yes.
Yes,
Yes. Unfortunately, I considered this to be a good question, so I think I have solved it earlier. Okay, so you see, in this, what we have to do is that, let us say that it is given that you are taking 1 liter of sample. Let us say that it is containing X ml of O3. So how many moles it will be? X by 22,400 moles. And how many millimoles? X by 22,400 into 1000 millimoles. It is X by 22.4 millimoles of O3. Now X is volume in ml. Okay. I see ozone is decomposing to give O plus O2. I see N factor calculation of ozone through loss of electrons will be difficult because you see ozone is having 0 here and 0 here also. Actually, it is the nascent oxygen which is going to O2 minus, which is water. Okay. So whatever will be the milli equivalents of oxygen, N factor of nascent oxygen will also be the N factor of O3. So you see, nascent oxygen plus I minus will be giving I2 plus O2 minus. So its N factor will be 2 because it is taking 2 electrons per, atom. So if the ozone N factor is 2, then you see O3 is reacting with I minus, and I minus it is giving I2, and I2 is estimated by hypo. So let us say that molarity of hypo solution is M. Then milli equivalents of hypo will be M into 1 into N. Okay, so there is a 9M MEQs of iodine. Is because 9M MEQs of hypo is 9M MEQs of iodine. And that should be equal to 9M MEQs of ozone. Okay. Now 9M MEQs of ozone and N factor is 2. Then this means 9M by 2 millimoles of ozone. Now this and this should be same. So I can write 9M by 2 is equal to X by 22.4. Okay, this is my first equation. Okay. Second equation is that H2O2 reacts with I minus and it gives I2. And this I2 reacts with thiosulfate and the reaction is finished. Now the same thiosulfate solution means the same molarity is requiring 24 milliliter of solution for this whole process. So milliequivalents of thiosulfate will be how much? 24 into M. Okay. So what that will be also equal to milliequivalents of I2, and that will be also equal to milliequivalents of H2O2. And for H2O2, N factor is always 2. So it will be 24 M by 2 millimoles. It will be okay. So now molarity of H2O2 is given to be 5. Volume strength is given to be 5.675. So molarity will be 5.675 by 11.2. Now these two, now molarity into volume. Volume we are taking to be 12 ml. That will be equal to the millimoles of H2O2 which we have calculated through this process. So if I'm writing 24 M by 2 is equal to 5.675 by 11.2 into 12, I will get M to be approximately 0.5. If M is 0.5, I can put the value here. 9 by 2 into 0.5 is equal to X by 22.4. 2 and 22.4 will get cancelled out. X will be 4.5 into 11.2. Approximately it will be 50. So you see you have 50 ml in 1000 liters. So it will be 50 by 1000 into 100. It will be 5. Are you getting my point?
Yes, sir.
Yes, sir.
So with this, I have completed the paper discussion. Okay. So what I would ask you people is to go through the thermodynamics problems as well as the stoichiometric problem of this paper. See after this discussion how much you can do yourself. Okay? Are you getting my point?
Yes, sir.
And also go through the stoichiometry 3. Okay. Go through the advanced paper of stoichiometry 3 which was conducted 2 weeks before. Okay. So then we will be meeting again on Monday for the paper discussion.
Sir, will you share these notes?
Yeah, I will share these notes.
Okay.
Okay. So I hope that you people must have realized the points where you people are, like making small mistakes. Okay, always remember two things I would like to say. First, that wherever constant external pressure is mentioned, okay, along with adiabatic or isothermal means it is an irreversible process. So work done will be minus of P external V2 minus V1. Are you getting my point?
Yes, sir.
Okay, just this much to take.
Answer again, sir.
Okay, wherever constant external pressure is mentioned against constant external pressure. If this term is mentioned, then it is irreversible process. This means that W will be equal to minus of P external P2 minus V1. Getting my point?
Yes, sir.
Okay. So this is what I wanted to emphasize. Okay, let us see how you do in the tomorrow's paper. Don't be afraid if the paper is tough. It is tough for all of you. You should not expect always easy papers because you see, you have enrolled yourself in this SuperChaina program. So the papers are going to be good level. Okay. You means WTMs once in a while you might get an easy paper, but UTMs will be on a good level. Okay. So what I am expecting is that you people be prepared to the previous paper of WTM for stoichiometry, and please go to the last week's paper for thermodynamics, work done calculation. Is it clear to all of you?
Sir.
Yes,
Okay.
Yes, sir.
So
Yes,
best of
sir.
luck for tomorrow's exam. Let us meet on Monday. Okay. I will post the notes. Okay.
thank you, sir.
Thank you.
Okay.
Thank you, sir.
Thank you, sir.
Thank
Okay.
you, sir.
So I am just concluding the meeting. See, if there is any part where you had any confusion, then the meeting was recorded, so you can look into the recorded lecture also. But do not waste too much time because we have gone through the whole meeting very nicely. Okay.
So do we have maths class?
Yeah, you will be having a math class at 5:30. Okay. So I am ending the meeting for all of you. Okay. Thank you, people.
Thank you, sir.